Hi guys, I want to do a brief overview of your first lesson in calculus. Calculus deals in motion, and anything we have done previous to this has been rather static and kind of stationary. You're going to see some things that look familiar, but we're going to build upon them and kind of elaborate on them a little bit more. So first lesson is going to deal with limits, which is a fundamental concept in calculus. Let's take a look at this function. Now, we can see that if x equals 2, my function would be undefined. So 2 is outside of the domain. You might want to say, well, there's a vertical asymptote at x equals 2. But remember, if we factor that numerator, that x minus 2 factor will cancel out. We'd be left with x plus 2, which is linear. Now, what we didn't really go over in the past because we hadn't made it there yet is when you're in a situation like this, you actually have a little hole in the graph at x equals 2. So it's a linear function, but then where x is 2, there's a hole there in the graph. So we're going to construct a table to analyze the behavior of f as x gets closer to 2. Now we're going to choose maybe 2 or 3 values that are a little bit less than whatever number we're looking at, and a little bit more. This is as x approaches my 2 from the left on the graph, and here is as x approaches 2 from the right. So we're coming in from the right. And what we want to do is we want to find out, well, what are the y values doing? Are they approaching a single y value? This is all calculator work. You're taking these numbers, plugging them in. Here's your output numbers. If we look as we're coming in to where that hole is on the graph, well, my y values are creeping up on 4. They are approaching 4. That is our limit. So here's how we read it. The limit of the quantity x squared minus 4 divided by the quantity x minus 2 as x approaches 2 equals the number 4. Here it is in limit notation, and here is your definition limit notation. This little a value here where the x has the arrow, that means as x is approaching whatever number, where are my y values going? What are my y values approaching on? Well, that's your limit. This is VIP. As x gets closer to a but remains unequal to a, the corresponding values of f of x get closer to L, your limit. Let's look at a few examples. Notice 1a, domain is all real numbers. Okay, but remember, we're not really focused on that. We're looking at the behavior of the graph. We want to know, what is the graph doing? Is the graph approaching a certain number as x approaches 4? Where are my y values going? Are they approaching a certain y value? So here we go. Again, here's my a value is 4. I've chosen 2 numbers that are a little bit less and 2 numbers that are a little bit greater. Plug them into the calculator. Here's my output values. So as I'm looking at this, as x is getting closer to 4, where are my y values going? Well, they're going to have a limit. They're going to approach 48. So the limit is 48. Here we have some trig. Please remember, when you're plugging these into the calculator, your calculator needs to be set on radians. So division by 0 is undefined, but again, that is really not important. We're looking at the behavior of the graph as x approaches my a value of 0. So here we go. On this one, we've done 3 different values, a little bit smaller than 0, a little bit greater than 0. You plug them into the calculator and look at your output values. As we are getting closer and closer to 0 on both sides here, what number are we approaching? Well, we're approaching 1, so my limit is 1. And let's look at a graph. Let's do this using a graph. A, limit of f of x as x approaches 4. Okay, so here's my graph. Here's x equals 4. As I'm coming in on this graph, what y value am I approaching? Well, I'm approaching 7, so the limit is 7. Now if I want to evaluate f of 4, Okay, so here's my x value of 4. What's my output? What's the y value? See the closed dot? That is your y value. It is 2. Now let's look at the limit of f of x as x approaches negative 2. Here's negative 2 coming in from both sides. Here we go, and my y value is going to be 5. And now f of negative 2, here's negative 2. What's my y value? It's the closed dot, which is 3. Notice here my limits were the open dots. My actual values when I evaluated the function were the closed dots.